In this video, we're going to discuss margin of error. Margin of error is a way for us to use sample data to represent a population without shooting ourselves in the foot. Okay, so kind of what I mean by that is when you are going to make a statement about, say, a population of 7.5 billion people in this world, okay, and that statement is based off of you sampling I don't know, say 100,000 people. That might seem like a lot of people, but compared to 7.5 billion, it's not a whole lot, right? So if I'm going to say, based on my sample of 100,000 people, 52% of the world tuned in to watch the Super Bowl, I don't know if I want to just report that 52% out as a hard number or as an interval and say maybe it's between, say, 45% and 55%. Okay, by reporting it out as an interval, using that margin of error of, in this case, 5%, it hedges my bet a little bit and it keeps me from saying something that's false or inaccurate. Okay, because at the end of the day, I truly don't know what the true population is who watch the Super Bowl. All right, I like to think of the margin of error as an analogy to the game of golf, and the fairway acts as a margin of error. Basically, what that means for those unfamiliar with the game, if you land the ball in the fairway off the tee, okay, you have a greater chance of hitting that ball pure on your second shot. Okay, meaning the ball is going to lie on a patch of grass that is much shorter than the longer stuff known as the rough. Okay, it's a little more difficult to hit the ball out of the rough than it is to hit the ball. I should say a lot more difficult than it is to hit the ball out of the fairway. Now, every hole is different and every fairway is different, but one thing is for sure that hitting the ball off the fairway is going to be an easier route to the hole than hitting the ball from the rough. A golfer has to dictate his or her plan on that first shot off the tee based on the fairway, right? So what I did here was I tried to come up with two holes of golf where the fairways are very different. Okay, and notice the first one. The hole's all the way over here. Okay, somewhere up here, and the tee is kind of behind us here. But what we can figure out here is the fairway. And if you look closely, you can kind of see the outline from the rough to the fairway. It's pretty wide, and not only is it wide, there's nothing else around. I mean, there's a cart path over here, right? There's a couple trees that really haven't grown in yet. There's a sand patch, sand trap over here. The hole's back here. It's pretty wide open, right? So if I'm playing this hole, I can, in a golf term, I can grip it and rip it. I can tee up a driver and try and hit that thing as hard as I can, knowing that I have a pretty large room or margin for error. So if I miss hit and I slice it, which means I hit it off to the right, or I hook it and I hit it off to the left, I'm still going to be okay. Okay. Let's look at this hole. All right. This hole's a lot different. Now, obviously taken from a different angle, but already you can see that this is a much narrower gap than we had up here. Okay. Also notice how there's trees overhanging. It just creates a much smaller margin of error. So instead of gripping and ripping it, quote unquote, on this tee, right, I can't just swing out of my shoes. I have to control myself. I might hit a smaller club instead of using my driver. I might use what's called a 3-wood or a hybrid or even an iron because I have more control with that club. I'm not going to get as much distance, but I'd rather sacrifice the distance, right, to stay out of this tree line and to stay out of this tough part of the hole. Okay, so how does this relate to statistics? Well, we talked about in the previous video being lazy. It leaves you more room for error, right? Or in other words, if I get a smaller sample size, um, it's more variable, right? So I relate this first hole to, like, say selecting a sample size of 10, right? If I only select 10 people, as I change from sample to sample, my results are gonna kind of float all over the place, right? I might have one sample over here, I might have one sample over here, I might have one sample in the fairway, right? Whereas for something like this, I can't be as lazy, right? I have to be a little more focused. I have to care a little bit more about how I'm selecting that sample. Maybe I select 100 people now in my sample. Those results from those samples are going to be less variable, right? Maybe one lands over here, one lands over here, one lands over here. One does lie outside of the fairway, but for the most part, I'm going to have much more consistent results. Okay. Now, again, now let's take a break from the golf analogy here. What is margin of error, and what does it do for us? Originally, I said it is an estimate for standard deviation. Okay, so let's start there. It's an estimate for standard deviation, and we'll talk about standard deviation as we get deeper into this course, and we'll come up with an actual calculation, okay, for standard deviation. Now, margin of error, and I'm going to just abbreviate it as MOE, is always equal to 1 over the square root of n. Okay, this is an important equation. You'll have to use this to get margin of error, where n is your sample size. Okay, so let's say, for example, my sample was 20,000 people. To get the margin of error, I would do 1 divided by the square root of 20,000. Take the square root of 20,000 first, and then divide it into 1. Okay, now, what does this mean for us? Once we had this margin of error, we take our sample proportion, which is p hat, and we can add and subtract that margin of error. And it's going to give us a result. Okay, again, this p hat, that is our, we'll say sample percentage. I like using the word percentage more. Okay, and that's going to give us a range. And I'm just going to use the variables of x and z for now. Just those are going to be two numbers or two percentages. Okay. And then once we have those two percentages, what it tells me is 95% of my samples will fall between x and z. Right? Now I've only done one sample, but let's say I did 99 more. Okay, out of 100, 95 of those would fall between x and z. And I think this will all make a lot more sense when we go through an example. All right, so let's do that right now. And let's say the variable of interest is, I'm just going to do this in a different color so we don't get confused here. The percentage of people watching the Super Bowl. All right. And the reason I select this variable is because I don't know. I don't know what that number is going to be. I don't know what that percentage is. It's not feasible to go about polling all 7 billion people in the world and asking them, are you going to watch the Super Bowl or are you not? It's a very difficult process to do. So instead, I could select a random sample. We'll say we select a random sample of 100 people. Okay, and in that random sample, and again, we selected that randomly from all people all over the world. Maybe only 2 people from the U.S. and other countries. I mean, all over the place, right? And out of those 100, we'll say, just kind of bullet this here. We'll say 60 people, 60 out of those 100 say they watched it. That's a pretty high number, probably an overestimate. What's my margin of error, and then more importantly, what's that interval of x and z that borders my fairway, so to speak, right? Well, let's figure it out. We start with our sample proportion, which is p hat, and in this case, it's going to be 60 out of 100. Right? And just as a general term, before we calculate this, if you're ever confused with how to get p hat, you always start with the number in the bottom as your sample size, and then up top we say is the number of successes. Okay, in this case, a success would be a person watching the Super Bowl. Okay, so 60 out of 100 gives me 0.60 or 60%. Now again, before we calculate the interval, I don't know why that won't let me write a percentage. There it is. Before we calculate the interval, let's talk about why it's important to calculate the interval, right? Again, remember, I'm talking about all the people in the world, and I'm basing this off of a sample of just 100 people. So I would be very naive to think that this 60% is set in stone and, you know what, I can take this number and broadcast it out and publicize it in a newspaper article, whatever it is, and say, yep, 60% of the world, they're watching the Super Bowl. No way, right? It's only based off 100 people, so that wouldn't work. I want to give myself a little bit of margin of error. So again, I hedge my bet on me not being as accurate as I can. So, all right, so here's my fairway, okay? Here's my X, and here's my Z, and my 60% is somewhere in between. Now I want to figure out the width of that fairway, okay? And what that width is, again, that's your margin of error, right? That's a percentage that we're going to calculate in just a minute. It splits up your fairway here in the middle, okay? Margin of error to the right, margin of error to the left. That's what it's going to look like, okay? All right, so margin of error is the square root, or I should say 1 over the square root of n, which is equal to 1 over the square root of 100. Notice we picked a nice, easy, perfect square to work with. Square root of 100 is 10. So my margin of error in this case is 0.10. And again, I like using percentages, so we can convert that 0.1 to 10%. Okay, so I can go 10% this way. I can go 10% this way, right? And my interval, instead of, again, reporting out a number of 60%, I'm going to say, you know what? 50%, anywhere from 50% to 70% of the world is going to be watching the Super Bowl, okay? Am I that accurate? It's not as accurate, right, as saying 60%, but again, it's only based on 100 people. So I feel more confident and more comfortable in saying it this way than just reporting out 60%, all right? Now, again, let's go back up to the last part of this definition here. And it says 95% of my samples will fall between X and Z. All right. So again, in our case, we figured out the lower bound to be 50% and 70%. So what that tells me is if I were to conduct this sampling process 99 more times, 94 of them, in addition to the one I just did, 94 of them plus the one I just did, the sample proportion should fall between 50% and 70%. The other 5%, those are going to be the ones that fall outside the fairway. You guessed it, right? They're going to fall on the cart path or in the trees or in the sand pit over here, right? And that's what we want to try and stay away from, okay? So if going back full circle here, if this fairway represents that margin of error we just calculated, okay, remember we said this one was the wider one, the easier golf hole, the one we can grip it and rip it on, right? Our margin of error is 10%. This would represent a smaller margin of error, right? And I don't know what that number is off the top of my head. I know it's less than 10% down here, but what I could say for certain is that this picture over here would represent a higher sample size, right? This would be a higher sample size, without a doubt, because a higher sample size is going to reduce the margin of error. It's going to require more care and intensity and focus on my part, just like a golfer. But ultimately, in the long run, juice is worth the squeeze because I'm going to get a more accurate result, and I'm going to get a more consistent result, thus reducing variability.